I meant to pause that last video. So in this next video, what I'll do is I'll quickly run through problem numbers 2, 3, and 4. I might have to pause it and just show the solutions for 2, 3, and 4. But what I'd like you to do before I run through number 2 is I'd like you to try it on your own. So if you haven't already done number 2, go ahead and pause the video now, because I'm going to go ahead and walk you through how to do number 2. Second memory, reset, all RAM, reset. So it just gets rid of everything. We can start with a fresh slate here. And then we go to Stat, Edit. We're going to edit our lists. So we have 2, 5, 1, 0, 4, 2, and 3. Okay, the other numbers are 77, 92, 70, 63, 90, 75, and 84. Let's make sure we understand what this data is. Make sure that it already says X and Y, but it says the table below gives the number of hours spent studying for a science exam, X, so study hours, and the final exam grade, Y. So the final exam grade depends on the number of hours spent studying for the science exam. So that's good. That is a dependent variable. And then let's go ahead and hit Stat, Calculate. Oops, meant to do that differently. Calculate and then hit number 4, linear regression, and we're going to store that in Y1. Vars, Y variables, function mode, Y1, enter, enter, and we've got our line of best fit. So that takes a lot longer to explain in detail how to do this stuff than it does to actually do it. So our line of best fit, let's leave it as f of x is equal to 6.09, 6.09, 2 digits after the decimal, plus 63.93, 63.93. There's our line of best fit. It's already stored. If we want to graph it, we can. Y equals, select the plot 1, select it, and then go ahead and hit, oh, see now if we did graph, I said zoom 9 before, so sometimes I forget. So zoom, I'm going to wait for a minute, zoom stat, zoom 9, that gives us a better idea. Again, the x coordinate represents the hours spent studying for the science exam, and the y coordinates represents the final exam grade. So it says predict the exam grade of a student who studied for 6 hours. So what do we want here? We want a grade, so we want the y when the x is 6. Okay, so if we want the y when x is 6, what do? Well, we calculate f of 6. f of 6, we're going to use our y1, okay, just like we did before. And how do we do that? We go to vars, y variables, y1, put parentheses around the 6, and we get our what grade. So I put that in, it should have been like 5.5 hours. So we expect this person to get 100%. Okay, so sometimes the data is, the line of best fit can only be so helpful. But anyway, that is the grade that we're expecting. If you study for 6 hours, you're expected to get 100%. And then the next question is, how many hours? So hours is the x. Would you expect that someone spent studying who got an 81 on the test? That's our y. So x is the unknown, and so we want to figure out when f of x is equal to 81. We want to know the x, so that's the unknown. We don't know what the x is, so if we don't know what the x is, this is the value that we plug in for our y2. So let's do that. Go to y equals, go down here, we want to know, well, when is the y1 going to equal 81? And let's make sure our window shows 81. Yeah, we have a y max of that. And so we can go ahead and go down here to, remember, XRES 3. It's going to draw it a lot faster. Okay, so that's right there in the middle. Second, calculate intersect. Enter, enter, enter. And we've got our 2.8039735. So 2.8 hours of studying. So we expect 2.8 hours. And that's how much time we expect that person to study to get 81 on the test. All right, let's do number Number 3, I think that's a 5-minute video, so I think perhaps I can just walk you through each one of these. It doesn't take very long. Let's see here, we've got table of lengths and corresponding ideal weights. So length and weight, we could go either way on that, but let's go ahead and list in terms of the independent dependent variable, not necessarily one or the other here, but length, I would say, since it's listed first, we'll call that the x, and we'll call y the weight, and we'll go from there. Okay, so again, we go back to second memory, 7, 1, 2, and we've got that. Go to stat, edit, and we'll put the values in. So let me get those values here. Okay, well, 60, enter, 62, 64, 66, 68, 70, and 72. How convenient. Okay, and then we have a 105, we have a 114, 124, 131, 139, 149, and 158. So we're going to go stat, calculate, linear regression, enter, vars, got to go y variables. We're going to store this regression equation in our y1, and then we're going to write it down. Okay, so there we go. There we have our regression constants anyway, and that means that we have f of x equals 4.36x minus 156.14. So that's our regression equation. That's our line of best fit. And then we want to predict the weight, so we want to predict the y when the x is 75. So f of 75. So if the x is 75, we want to find f of 75. So we want to find the weight. So this again, f of x, that's the weight at x inches. Okay, so the weight as a function of x number of inches that sand shark would be. So f of 75, we're going to type in y1. Oh, we don't want to go there. Vars, y variables, enter, y1 of 75 equals. And then we have a weight of 170.64 pounds. Is it pounds? Pounds? It doesn't say pounds. Oh, it does say pounds down there. So it doesn't really say pounds until the very end. Okay, so pounds, and then we're going to box around that. And the next part, I'm almost at 9 minutes now. After I finish this example, I won't explain the fourth one, and I'll have you just do it, and you can check your answers. Okay. What length would you predict? So length, that's the length is the x. So what x would you predict that the sand shark that weighs 170, oh man, so we got really close there, 170 pounds, that's the y. And so we want to let f of x, we don't know the x, but we know the y is 170. Okay, so imagining it'll be really, really close to 75 inches. Okay, so what do? We go to y equals, set y2 equal to 170, and then we want to make sure that our y max, oh, we hadn't even done the stat plot yet. Stat plot, we can do that, and we'll plot that as well. And then we might as well go zoom standard, or zoom stat. So there's our zoom stat, forgot about that part. Don't really need it until now. However, that does adjust our window nicely. So we go to our window, we want to make sure our y max is above 170. So let's put that as a 190, let's say. And then again, the x-res of 3, and that should be good enough. What's the weight? Oh, the weight's 75, so that's the x. Let's go back up there and adjust that to 80. Okay. So then we can see the intersection point. Second, calculate, intersect, enter, and we get 74.85. And so 74.85 what? 74.85 inches. we expect that a sand shark that weighs 170 pounds would be 74.85 inches. And there you go. Pausing the video, and I'll do number 4. Do number 4 on your own. Make sure you know how to do it. Well, that was kind of interesting. I made a mistake on my f of x, and I didn't realize that until I looked at my line of best fit. And what happened was my line of best fit, I'll show you what it looked like initially. I had input the 11, and I wasn't paying attention. I input the 11 as a 1. So then when I graphed my line of best fit, oh, I'd have to calculate that again. Second, calculate 4. Okay, put it in the Y1, enter, enter. Anyway, when I calculated my line of best fit, I looked at my line, and there was a dot way down there, and then the line was underneath all the other dots. So I knew I did something wrong. So just be careful, anyway, be careful when you enter your data, because when you enter your data, if you miss one little thing, it's going to mess everything up. Okay, so let that be a lesson. Anyway, I double-checked my data, and I double-checked my calculations. So this is your line of best fit. So f of x would represent the shoe size of a man, shoe size of a man who is x inches tall. Okay, so x inches tall, and so the first one, if the shoe size were 10.5, that would mean f of x equals 10.5. What's the predicted height? So the height being x, so the first thing, f of x equals 10.5. Excuse me, 10.5. So x would have to be 71.98 inches, and then the other one was 15.56. Have a great night.